Q3287. An airplane has been loaded in such a manner that the CG is located aft of the aft CG limit. One undesirable flight characteristic a pilot might experience with this airplane would be A. A longer takeoff run. B. Difficulty in recovering from a stalled condition. C. Stalling at higher than normal airspeed. The correct answer is B. When the center of gravity, CG, of an airplane is located aft of the aft CG limit, one undesirable flight characteristic a pilot might experience is difficulty in recovering from a stalled condition. An aft CG position reduces the stability of the airplane, making it more prone to pitching moments and increasing the difficulty of recovering from a stall. The aft CG causes the tail to exert less downward force, reducing the effectiveness of the elevator in controlling the aircraft's pitch attitude. As a result, the airplane may have a tendency to pitch up further during a stall, making it more challenging for the pilot to regain control. 3288. Loading an airplane to the most aft CG will cause the airplane to be A. Less stable at all speeds. B. Less stable at slow speeds, but more stable at high speeds. C. Less stable at high speeds, but more stable at low speeds. The correct answer is A. Loading an airplane to the most aft center of gravity, CG, will cause the airplane to be less stable at all speeds. The stability of an aircraft is affected by the position of its CG relative to its neutral point. The neutral point is the point at which changes in the airplane's angle of attack do not produce any pitching moments. When the CG is located aft of the neutral point, the airplane becomes less stable. This means that it will have a tendency to be less responsive to control inputs and more difficult to control. The destabilizing effect is present at all speeds, not just specific speed ranges. 3211-1. Changes in the center of pressure of a wing affect the aircraft's A. Lift/drag ratio. B. Lifting capacity. C. Aerodynamic balance and controllability. The correct answer is C. Changes in the center of pressure of a wing affect the aircraft's aerodynamic balance and controllability. The center of pressure is the point on the wing where the lift force is considered to act. When the center of pressure shifts, it can affect the balance of the aircraft, specifically its longitudinal stability. If the center of pressure moves too far forward or aft, it can result in an imbalance that affects the controllability of the aircraft. For example, if the center of pressure shifts aft, it can cause the aircraft to become more nose-heavy, leading to increased stability but potentially reduced maneuverability. 3217. The amount of excess load that can be imposed on the wing of an airplane depends upon the A. Position of the CG. B. Speed of the airplane. C. Abruptness at which the load is applied. The correct answer is B. At low speeds, the wing's maximum lifting force is only slightly higher than what is needed to support the weight of the aircraft. However, at high speeds, external factors such as the capacity of the elevator controls or a strong gust of wind can increase the load factor beyond safe limits. The load factor refers to the additional force exerted on the aircraft structure due to maneuvers or external forces. If the load factor exceeds the aircraft's structural limits, it can lead to structural failure or loss of control. Therefore, it is important for pilots to be aware of their aircraft's limitations and to operate within the safe load factor limits to ensure the aircraft's structural integrity and flight safety. 3218. Which basic flight maneuver increases the load factor on an airplane as compared to straight and level flight? A. Climbs. B. Turns. C. Stalls. The correct answer is B. The basic flight maneuver that increases the load factor on an airplane as compared to straight and level flight is turns. When an airplane is turning, centrifugal force acts outward from the center of the turn, creating a force that is perpendicular to the wings. This force, known as the load factor, increases the total load on the wings. The load factor is directly proportional to the bank angle of the turn, meaning that steeper turns result in higher load factors. Climbs and stalls do not inherently increase the load factor on an airplane.